So 6.6, we're going to be taking the inverse of functions, and we've actually been working with inverses a lot longer than we might think. For example, we have what's called the additive inverse. Okay, do you guys remember what additive inverse is?
Additive inverse sounds...
It goes all the way back to pre-algebra. Okay, additive inverse is what we add to something to get 0. So let's say I give you the number 4. What would the additive inverse of that be?
Negative 4.
-4. Okay, we also have what's called multiplicative inverse.
Oh, yeah. Get it to be 0.
Not 0.
Or not 0, it's
1. So if we're multiplying something and we want to get it to 1, let's say I give you 2/3. What would you multiply 2/3 by to get 1? 3/2. So we have additive inverse, which is the opposite. We have multiplicative inverse, which is the reciprocal. And now we're going to be taking inverses of functions. So we have a definition. When, here, let me say this again. Inverses of functions. Functions are inverses of each other if f of g of x equals x and g of f of x equals x. So if we want to check that two things are inverses of each other, we compose the f function with the g, and then we compose the g function with the f, and when we simplify, we should get x both times. Okay? If a function, let's say our original function is f, and g is the inverse of f, we can rewrite it as f to the -1, and we read that as f inverse. So if we ever have f to the -1, that means that f is the inverse, that's the inverse of f, and we can read it as f inverse. So we also have just a notation how we denote these things. If our original function is f of x, then the inverse is f inverse of x, which we just said. If our original function is, for example, y equals something, then we can just write the inverse as y inverse. So you don't have to change it to f of x all the time. If it comes to you as a y, you write your answer y inverse. Okay. So we have a couple steps in finding the inverse. Okay, so how do we find the inverse? So if I give you a function and then I ask you to find the inverse, our first step is that we want to exchange x and y in the equation. So our y becomes x and our x becomes y. All we do is switch them. Then we solve that equation for y, just using the regular solving methods we've been doing all year. And after we've solved for y, instead of writing y equals, because we're finding the inverse, we rewrite it as y to the -1, denoting that it is an inverse. So after we solve for y, we need to make sure that we rewrite it as y inverse, so that way we know that what we found is actually the inverse of something. Example 1. We have y equals -3x plus 2. That's our function. And what we want to do here is our first step, we want to exchange x and y. So instead of y equals, we're going to write x equals. So x equals -3, and instead of x, we're going to put y plus 2. So all I did here was I rewrote it, but I switched the x and y. So how do we solve for this? What should be my first step in solving? Very good. I subtract 2 from both sides. So that's going to give me x minus 2 equals -3y. And then I want to solve for y. What do I do then? Good, divide by -3. Now, one word of caution right here, when we're dividing both sides, we need to divide the whole thing by -3. So make sure that you put the division under the whole thing. So those guys are going to cancel, and we're going to get y inverse, because we need to change it to the inverse, equals x minus 2 over 3. And that's our answer. That's all we have to do. Okay, so y equals -2/3 x plus 7. So what we want to do, first step, is switch the x and the y. So this is actually going to be rewritten as x equals -2/3 y plus 7. Okay? And then all I need to do here next is solve for y. I have two methods I can do here. I can subtract 7 and then multiply by the reciprocal to get rid of that, or I can cancel out the fraction now. Which way do you guys want to do? You want to cancel out the fraction now? Okay, so what do I need to multiply both sides of the equation by to cancel out the fraction? 3, because we want to get rid of that 3 denominator. So let's multiply the left and the right by 3. Okay, so on the left, that's going to give me 3x equals, now when I distribute that 3 into the parentheses, these guys cancel, so it's going to be -2y plus 21. Good. So you need to make sure, and this is something that we all struggled with at the very beginning of the year, you need to make sure that you distribute that 3 to the whole thing. So you need to multiply the fraction by 3 as well as the 7. Okay, so now solving for y is a piece of cake. What do I have to do first?
Wait, so it doesn't matter what you solve for, x or y?
You have to solve for y. We want to solve for y, because we're trying to get it back as a function. We subtract 21 because we're solving for y, and that's going to give me 3x minus 21 equals -2y. And then we divide by -2. So let's divide both sides by -2 because these will cancel. And so what's my answer? This is not y now. We're taking the inverse, so it's y inverse equals 3x minus 21 all over -2. I missed my negative there. So pretty much all we need to do for these problems where we're finding the inverse, switch x and y, and then solve for y, because we're trying to get it back to another function. And if we have x equals something, we're not a function. We're looking for y equals. Does that make sense? Okay. For example 3, we're actually looking at a square function here. So we have f of x equals x squared. So what we can do here to make it a little bit easier on ourselves, we can actually replace f of x with y. So I'm just going to rewrite this whole thing as y equals x squared. Just because then it's easier for us so that we can follow the same steps of switching x and y and then solving for y. But because our original function was given in f of x, we want our answer to be f inverse. So we're going to have to change it back later at the end. Okay? So all we need to do here is we switch x and y. So this becomes x equals y squared. And how do I solve for y here? How do I get rid of the square? Take the square root. So let's take the square root. So we actually get square root of x equals y. But remember, our original problem is f of x, so we're just going to rewrite y as f inverse of x, because that's actually what we found, right? The inverse equals square root of x. You guys okay with that? All I did here was I changed f of x to y just so that we're following the same steps that we've been doing, because f of x and y mean the same thing. Okay? But because my original problem had f of x as my function, I just need to make sure that my answer is f inverse of x. So that's the only reason why they changed. Okay? Otherwise, we could rewrite this as y inverse, right? Okay? So example 4. F of x equals -10 x to the 6